pedestrian and bicycle adjustment factors. These factors are included in the saturation flow equation to account for a reduction in the saturation flow rate resulting from the conflicts between automobiles, pedestrians, and bicycles. So we have here the procedure can be divided into the following four main tasks. Number 1, determine the average pedestrian occupancy. Number 2, determine the relevant conflict zone occupancy. Number 3, determine the permitted phase pedestrian bicycle adjustment factors for turning movements. And number 4, determine the saturation flow adjustment factors for turning movements. Step number 1. In this task, the pedestrian flow rate is the first computed from the pedestrian volume using equation number 10.41, 10.42, and 10.43. So you see the equation over there 10.41, 10.42, and 10.43. So where VP EDG equals pedestrian flow rate, while VPED equals pedestrian volume, and then GP equals pedestrian green walk plus flashing don't walk time. If pedestrian signal timing is unknown, GP may be assumed to be equal to G. C equals cycle length second. Take note that the equation 10.42 and 10.43 is not necessary to compute VPED from equation 10.41 if pedestrian flow rates is collected directly from the field. Step number 2, OCC. The two conditions influence the computation in this factor. These are 1. Right turning bicycle and automobiles waves to the right before reaching the stop line. And number 2, left turn movements are made from the one-way street. When the first condition exists, the bicycle or automobile interaction within this intersection is eliminated. The bicycle volume should be therefore be ignored and only the impact of pedestrian should be considered. So step number 3, determine permitted phase pedestrian bicycle adjustment factors for turning movement. So we can see is APBT equals 1 minus OCCP times NTARA equals NREC. That is 10.50 equation. Step number 4, determine the saturation flow adjustment factors for turning movements. FIPB equals 1.0 PIT times 1 minus APBT times 1 minus PITA. This is equation 10.52. Where PIT is equals to proportion of the left turn volume and APBT equals permitted phase pedestrian bicycle adjustment factor for turning movements. VITA equals the proportion of left turns using protective phase. So VRPH equals 1.0 PRT times 1 minus APBT times 1 minus PRTA, where PRT is equals to proportion of the right turn volume, APBT equals permitted phase pedestrian bicycle adjustment factor for turning movements, PRTA is the proportion of the right turn using protection phase. Field determination of saturation flow. An alternative to use the adjustment factors is to determine directly the saturation flow in the field. Saturation flow equals 3600 over t4 minus t n over n minus 4. This is 10.54 equation. Uniform delay. The uniform delay is which will occur in this lane group in vehicles arrive with a uniform distribution and situation does not occur during any cycle. Incremental delay. The incremental delay takes into consideration that the arrivals are not uniform from random and the summed cycle will overflow. D sub 2 I is equals to 900t times the quantity of x sub I minus 1 plus square root of the quantity of x sub I minus 1 squared plus 8k sub I times I sub I x sub I over c sub I times t, where 2 sub I is incremental delay for lane group I, c sub I equals capacity for the lane group I, t is duration of analysis period. K sub I is incremental delay factor that is dependent on controller settings. I sub I upstream filters metering adjustment factor accounts for effects of filter arrival from upstream signals. X sub I is equals to V over C ratio for lane group I. Residual demand delay. This delay occurs as a result of an initial unmet demand QB vehicles at the start of the analysis period T. Residual demand is obtained from equation 10.557 as D sub 3A equals 1800 Q sub BI times 1 plus U sub I times T I over C I times T. Q sub BI equals initial unmet demand at the start of a period T sub I vehicles for the lane group I. C sub I equals adjusted lane group capacity VEH over H. T is duration of analysis period which is H. T sub I equals duration of unmet demand and T for lane group. U sub I equals delay parameter for lane group I. And T sub I equals 0 if Q sub B equals 0, else TY equals minutes quantity of T, QBI over CI times 1 minus minutes times 1, X sub I quantity. This is 10.58 question. U sub I equals 0 if T sub I less than T, else U sub I equals 1 minus C sub I times T over Q sub BI quantity of 1 minus min times 1, X sub I. That is the equation 10.59. Where X sub I is the degree of saturation for the lane group I. Total control delay. The total control delay for the lane group is I is given as D sub I equals D sub II times PF plus D sub I plus D sub 3I. That is the equation given 10.60. Intersection delay. The average intersection stop delay is found in a manner similar to the approach delay. D sub I equals to summation of D sub A times V sub I over summation of VA from A to sub X, and then the other one is summation of from A equals to 1 to A. That is equation 10.63.